What I would like to talk about in this section of the course is something which is tangential to the actual principles of programming language course. But I think that once we actually met the concept of transfer of ownership, I want to show you where it went to, which I think is a nice way of showing how things develop in programming languages over time. So in C++, we already discussed the idea of transfer of ownership. And the idea actually is that we go and we transfer the heap memory of some object to some other object, right? So we saw, for example, in order PTR, the same is true for unique PTR. The idea is that if we go and we assign from A to B, let's say we say B equals A, so we assign from A to B, then B actually takes over A's heap and this is B, and leaves A without its heap, just with a null, right? This is A. This is transfer of ownership. This concept actually developed into a totally new paradigm in C++ called move semantics. And I want to explain the idea behind it, and then I want to talk about just a high-level implementation of how it's done. The idea is very simple. We already know from previous lectures that there are things, and from Compiler's course, there are values which are L values, and there are values which are R values. Just to recap, L values are pretty much values which must retain their memory for future use. L values are allowed to be on the left-hand side of an assignment. R values are values which do not retain memory for future use, and therefore they are not allowed to be on the left-hand side of an assignment. So for example, we cannot write 7 equals A because 7 is an R value. So even though A might be an L value, and it can show up on either the left-hand side or right-hand side, but on the left-hand side of an assignment, you must have an L value, and therefore we must write A equals 7 and not the other way around. Okay? Now, we showed an example of creating R values. For example, writing A is equal to 7 plus 8. This number 15 here is an R value. Same is true if you write A is equal to B plus C. So B plus C, whatever B and C happen to be, creates some kind of R value, which gets assigned into A and gets discarded. So R values do not retain their value from command to command, while L values do. That's the first basic major distinction between them. Now, why is that important? Let's assume for a second that we have a function foo. And the function foo gets a value. Let's say a string. Let's say strings. So it gets a string, some string B. Okay? Now, suppose we have a string A, which is equal to, hello. And some string B, which is equal to world. And suppose we call foo using A plus B. Now, again, assume that operator plus is overloaded for strings and whatever, but the concept here is what's important. So notice what happens. Well, first thing that happens is we create a temp. Let's call it temp for lack of a better name. Create a temp which would equal to hello world. And then we transfer the temp into the function and we give it to the local variable string B. Now, this is a very high-level description. Let's dig deeper a bit into what's going on. A is a string. It looks like this. And it says inside hello. Now, B is also a string. And inside it says world, right? Now, when we write A plus B, we're actually creating a temporary string, let's call it temp, which points to some memory that says inside hello world, right? And this gets passed into B, which is also a pointer in a sense that needs memory, right? And now, if we just use the regular copy constructor for our strings or whatever don't care class that we want, it doesn't make a difference if it's a string or not. So let's just erase the word strings. You shouldn't think it has to do with strings and call this class don't care, which is the same idea. Now, if we would just use the copy constructor for class don't care, meaning that if we look at class don't care, it's actually defined like this, class don't care. It has a public, it has a constructor, and it has possibly a copy constructor. Right, and etc. It has destructor, obviously. Right, which would just say delete whatever. And it has the private value, which is the pointer itself. And again, I'm ignoring templates for a second. Now, this is just a basic outline of a class. Now, if we go back here and we ask ourselves, how would the copy constructor be implemented? I mean, think about it for a second. This is a call to the copy constructor, right? So how would you implement the copy constructor? Well, we all know that what we do is we go and we take the B and we allocate new memory for it at the size of strlen of strlen A plus strlen B, right? Plus 1 for the null, right? That's what we do. We create the size of hello world plus the null at the end, right? Obviously. And we just copy bit for bit, character for character. So we get the H and the E and the double O and the W, etc. We just copy the H, E, L, L, O, etc., 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 until we get to the D, right? And that's what we do. That's what a normal copy constructor would look like. Now, let's talk about the temp. Let's talk about the temp. Would something happen if instead of doing that, all of this, all we would actually do is reroute the pointer to here? Instead of allocating new memory and copying character for character and doing all this work, instead of all of that, suppose we went and we just went and we rerouted the actual pointer down to the temporary memory that was created by the A plus B. Suppose we did that. Would that be okay? Well, it depends. It depends what happens to temp. What happens to temp when it gets deleted? I mean, temp only exists from the minute we finished running the A plus B or the plus operator, right? The operator plus, until the time that it is passed into the copy constructor for B. After that, temp itself is deleted. We don't need it anymore. It doesn't exist. So the question is, what happens to temp's memory? The normal way that we learned how to do things using copy constructors, so temp's memory would also be deleted. All this will be deleted. And that's why we had to create a new memory and copy everything into it. Right? That was the whole idea. Because if not, then temp's memory would be deleted. But now that we created a new idea called move semantics, so we actually want to do something else entirely. What we want to do is say, okay, you created a temporary hello world. Okay, fine, I'm fine with that. Here's your temporary hello world. It says inside hello world. Let me take it away from you. I don't want to create this. I want you to transfer me ownership of your memory, and only the actual pointer will get discarded. Now notice that the final solution, the final picture is the same picture. We have a local B, which is pointing at a heap dynamically allocated memory called hello world, right? And it's the size that we want, and it's local, and we don't care that temp was there or wasn't there. So the pictures are actually the same. So if I use the concept transfer of ownership to steal temp's memory, I'm actually saving a lot of work. Which work am I saving? I am saving the work I had to anyway create temp, that I had to do anyway, create temp, and the memory that comes out of it. Why? Because that is the solution, that is the return value of the operator plus. It's a new temporary variable object with A and B within it. Let's say A plus B, hello world. So I have it anyway. Now, what I would have done is create another one, copy everything into it, and have B point to it. And then the next thing I would have done is delete all of this. I don't need it anymore. That's what I would have done. Notice the work. I am creating actually 2 objects per call because of this value, temporary value that I had to create. But if I use the move semantics, then I would actually go and create 1 temp. It says hello world inside it, which I had to do anyway because of the plus. And then I would steal it and delete just the pointer. And in a sense, use the concept transfer of ownership again. Transfer of ownership in order to save myself the calling of another constructor, the calling of another destructor, and all this for the temp that's in the middle, which is not really needed. So we actually learned a new concept called transfer of ownership, and notice this amazing implementation. The idea is have something more efficient and save yourself the copying and recopying of data. Now this would only work if the value that's sent here in the parameter is an R value. Why? Because in R value, we know for a fact that this memory from temp is not going to be needed further down the line anyway. It's actually a temporary, it's an R value. It's only there for the current command. It won't exist past the current command. If for some reason I call foo with an L value, let's say A, then this can't work because you can't have foo, right, stealing set order PTR. So you can't have foo stealing A's memory hello. So you actually have to use the regular copy constructor like we did till now. But if we know for a fact that the value that's being passed to the function is an R value, for example, the A plus B, right, which is just, it's not A, it's not B, it's somebody else, so we can just steal the memory. This is known as move semantics.